Hey everyone, we are going to now look at some graphs, and our job is to create equations given these graphs. So I want you to always follow this process. Step one, I wrote that wrong. Step one, find the y-intercept. So identify that nice easy point that you can always find on the y-axis. So in this case, I can find the y-intercept right here. I'm also going to find it right here on this other line, so I might as well just take care of one problem in both of those graphs. Step two, locate other nice coordinate points. On the line. Okay, other nice coordinate points on the line. So if I look at this particular line right here, it looks like I have a lot of nice coordinate points. Wherever it crosses really nicely with the grid, I'm going to make a little dot, just so that way I can see all of these nice coordinate points and I can focus on one of those for this. With this other graph over here, it looks like I don't have, oh, here's a nice one. Here's a nice one. Going backwards, here's a nice one. Here's a nice one. So there's fewer on this particular graph, but again, I'm looking for nice grid lines for each one of those. After I've found and located some nice coordinate points, I'm going to calculate my slope. And I'm going to pay attention to what slope dude would say. I'm going to hone in on my inner what would slope dude say question. So what would slope dude say? If I were to ask slope dude what he would say for both of these graphs, he would likely say puff, puff, positive for both of them because they are both positive sloped lines, meaning he is going to be working his way up the hill as he is getting ready to ski down it on the other side. So we have puff, puff, positive lines for both of these. I'm going to hone in on my inner slope dude. So that means whatever slope I end up finding for each of these lines, I would need to make sure that that slope is definitely a positive number. So let's look at this first line. I'm going to go from my y-intercept. It looks like I need to go up 1 unit, to the right 1 unit, and I can see that in various other parts of this. Up 1 unit, to the right 1 unit, up 1 unit, to the right 1 unit, and so on. So for this particular line, my slope is 1 over 1, or I could also say it's just simply 1. My y-intercept, we've already found that. My y-intercept is a negative 1, 2, negative 2. Once I found my slope and my y-intercept, I can go on to step 4, and I can write my equation. And I'm going to be writing it in slope-intercept form in that y equals mx plus b, and I'm going to change out the m and the b in my equation. So instead of writing m, I'm going to write positive 1. Instead of writing b, I'll write negative 2 for this particular equation. So this line, its equation is y equals 1x minus 2. You could also write this as x minus 2 because we know 1 times x is just simply that x. It doesn't matter if we write the 1 in front of it, but you're also welcome to just simply write 1x minus 2. You could also write 1 over 1x minus 2 just to like drive home the point of knowing that you have rise over run there. But it doesn't matter the format just as long as it's in y equals mx plus b, sort of this pattern here. If we look at this next line, let's find the slope because we've already found the y-intercept. The slope, it looks like I need to increase by 3, and my run is going to the right 4. So my slope, rise over run, rise up 3, run 4. My y-intercept, if I go back and look, from 0, 0, I went up 1, 2, 3, 4. My y-intercept is 4. So that means my equation is y equals 3/4 x plus 4 by substituting 3/4 in for slope and 4 in for b. So I have now created two equations for these two different lines. One more video after this, and we're going to look at how to make equations for nice negative lines, and then you will be set and ready to go and work on your must-do problems and the exit pass. Thanks for watching. I will see you in a moment.